Hello everyone, this is my second video of duality. In my first video, I explained two cases. Case 1 where objective function was minimization with all greater than equals to sign, and in case 2 the objective function was of maximization and all the constraints were of less than equals to sign. And now the case 3. Here the objective function is maximization with mixed constraints. So what is the meaning of mixed constraints? Here it means in the question you can see both the signs greater than equals to and less than equals to. So how can we solve this type of question? So before solving this question, we need to convert some constraints, signs of some constraints. How? You can see in this question, the objective function is maximization 3x1 plus 4x2 subject to constraints 2x1 plus 3x2 less than equals to 16, 5x1 plus 2x2 greater than equals to 20 and x1 x2 greater than equals to 0. This is our non-negativity condition. So you have to keep one thing in your mind. If your objective function is of maximization, then all signs should be of less than equals to. But in constant 2, you can see the sign is given greater than equals to. So first of all, we will convert this sign into less than equal to. How will we convert it? To convert the second constraint in less than equal to, we will multiply this constraint with minus 1 to both the sides, LHS and RHS. So in the solution you can see I have written, since the objective function of linear programming is of maximization, the direction of each inequality of greater than equals to type has to be changed. For this, we multiply the second constraint both sides by minus 1. So by this we will get, here you can see this is the second constraint. I am multiplying this constraint with minus 1 so that I can change the sign. So it will be 5x1. We will write minus 5x1. For plus 2x2, we will write minus 2x2. Now the sign has been changed, and instead of 20, we will write minus 20. So this is our new constraint. We will take this constraint in our primal now. So now primal is like this. Maximize z is equals to 3x1 plus 4x2 subject to constraints 2x1 plus 3x2 less than equals to 16. I have replaced the earlier constraint with this new constraint minus 5x1 minus 2x2 less than equals to minus 20, and the non-negativity condition is x1 x2 greater than equals to 0. Now we will convert it into dual. So do you remember the case 2? In case 2, we were having objective function maximization and all the constraints there were of less than equals to sign. Now the condition is same. We can convert it into the dual with the same rules which we studied earlier in my first video. So you can see in primal there are two variables x1 and x2. So if there are two variables in primal, there will be two constraints in dual. You can see I have written two constraints. If there are two constraints in primal, there will be two new variables in the dual. So there are two constraints, so I have written two new variables, that is y1 and y2. And how will we replace the numbers? For objective function maximization, I have written minimization. Instead of z, I have written g. These two values which are written on the right hand side of the primal will be written in the objective function of dual with new variable. So 16y1 minus 20y2. So this is my new objective function. I will write the constraints now. You can see the value in the first column is 2 and minus 5. So these two values will be written in row now. 2 and minus 5 with new variables 2y1 minus 5y2. Now the sign will be changed. Earlier it was less than equals to, now it will be greater than equals to. Greater than equals to, this value we have taken from the objective function of primal, that is 3. For the second constant, we will take the values in the second column of the primal, that is 3 and minus 2. 3y1 minus 2y2 greater than equals to value we will take from the objective function, that is 4. And now the non-negativity condition will be y1 y2 greater than equals to 0. There is some misprint. Values here are y1 and y2 greater than equals to 0. So this was case 3. I hope it is clear. Now we will proceed to case 4. You can see in case 4, the objective function is minimization and mixed constraints. So minimize z 5x1 minus 6x2 plus 4x3. And these are our 5 constraints, and this is a non-negativity condition. Here you can see the objective function is minimization. So whenever you see the objective function is minimization, the signs of the constraint should be greater than equals to. But in the third constraint you can see it is given less than equals to. So first of all we will convert this constraint into greater than equals to sign. How will we do it? We will multiply the whole constraint by minus 1. These things I have written here. Since the problem is of minimization, all constraints should be of greater than equals to. For constraint 3, multiply by minus 1 both sides. After multiplying, we will get the new constraint, that is minus 7x1 plus 2x2 plus x3 greater than equals to, instead of 10 we will write minus 10 because we have multiplied it by minus 1. Now all constraints have similar signs, that is greater than equals to. Now we can solve this problem as case 1. Do you remember the case 1? Case 1 was with minimization, objective and all greater than equals to signs. So now our problem is converted into case 1. You can see the objective function is minimization and signs of all the constraints are greater than equals to. And now the rules are same to convert it into dual. There are 3 variables, so there will be 3 constraints in dual. You can see I have written 3 constraints. There are 5 constraints in primal, so there will be 5 new variables in the dual. These are y1, y2, y3, y4 and y5. Okay, so I am converting it into dual now. Instead of minimization, we will write maximization, z, g, and you can see the value in the first column of the primal. These are 3, 1, minus 7, 1, 2. These will be written in the first constraint in row wise. Okay, 3, 1, minus 7, 1, 2 with new variables 3y1, 1y2, minus 7y3 plus 1y4 plus 2y5. Greater than equals to sign will be converted into less than equals to. This 5 we have taken from objective function of primal. For the second constraint, you can see the second column of the primal 4, 3, 2, 2, 5. So how will we write the second constraint? 4y1, 3y2, 2y3 minus 2y4 and plus y5 less than equals to minus 6 we have taken from the objective function of primal. And for the third constraint, the third column of the primal 6y1 plus 2y2 plus 1y3 plus 4y4 minus 3y5 less than equals to 4, which we have taken from the objective function of the primal. Now in non-negativity condition we will write y1, y2, y3, y4, y5. These are the new variables. All these variables are greater than equals to 0. So this is our non-negativity condition. So all 4 cases of duality are now clear. So duality is over here. I will send some questions of duality for practice, or you can take the questions from your textbooks and do practice. Okay, thank you so much.